I'm Terry Bradshaw. From emerging technologies and financial strategies to the latest healthcare developments, you would be surprised by the many factors coming into play. Welcome to Today in America. American industry is striving every day to become bigger, faster, and better. It's gone beyond the doorstep of the local production plant, crossing continents and oceans to span the breadth of new technologies, processes, and innovations. Join me as we explore the inner workings of an American industry.
One of the oldest and most trusted building materials known to man is concrete. Some 7.5 billion cubic meters of concrete are produced every year. But while its massive weight makes it perfect for some applications, it often proves to be too heavy for others. A new breakthrough in concrete manufacturing is changing all that with the addition of a surprising ingredient. Who would have thought a few bubbles of air could make such a difference?
Basic concrete consists of lime, volcanic ash, aggregates, and water, all naturally occurring materials, without causes for damage such as freeze-thaw and the rusting of internal steel caused by the penetration of water.
In the 1930s, a new technique emerged mixing tiny air bubbles with the concrete to lighten the material and any structure made from it. The resulting concrete foam is just as rigid as solid concrete and can bear an amazing amount of weight. This process never caught on in a big way due to drawbacks like inherent loss of volume, cracking, deterioration, and collapsing of the bubbles under stress. Cellular concrete technologies has finally perfected the concept, resulting in a construction material that is far lighter than its predecessor, yet able to bear reasonably heavy loads.
Well, what we've done is we've taken the concept of the atomization of fuel through a fuel injector. We force our fluid through these tiny chambers, which makes them into a fine mist. And these bubbles are so small that it's many times smaller than a grain of sand. And when you have it that small, it's very difficult to collapse the bubbles.
Stable air concrete can replace timber in many areas of home construction as well, reducing building costs and environmental impact. The air pockets give this material some insulation value, so heating and cooling costs are also reduced. Concrete is impervious to mold and termite damage as well, and will not burn like wood and resin products do.
A stable air concrete meets all local and national building codes, complies with all safety standards around the world, and is far more structurally sound than conventional concrete of today.
As a sustainable building material, stable air concrete can save money over traditional lumber in home and commercial construction, thanks to reduced maintenance requirements and lower energy cost. The product is highly resistant to damage from disastrous events like fire, hurricanes, tornadoes, and earthquakes. The material exhibits much less cracking and deterioration from the annual freeze-thaw cycles.
We use stable air cellular concrete because anytime you build a building out of cellular concrete, you've got all kinds of advantages. It's safer because it doesn't burn. It's much more energy efficient. You're going to save a lot of energy heating and cooling your house. And it also is a lot more durable. It's inorganic, so it's not going to be eaten by termites. It's going to be around for a long time.
Stable air concrete is approved by numerous states for road, highway, and bridge construction projects. Traditional concrete can corrode steel reinforcement elements like rebar, and as corrosion makes this steel expand, it cracks the concrete and pushes away whole sections of the structure. Since the stable air formula doesn't result in systematic corrosion of reinforcement materials, the chipping and cracking common to conventional concrete structures does not occur. Offering more protection from water penetration, it allows bridges and roadways to last several times longer. From single-family dwellings to high-rise buildings, from roads to roofing, and as a versatile flowable field, stable air concrete could rewrite the construction manual.